The Global Maritime Distress and Safety System is an international system which uses terrestrial and satellite technology and shipboard radio systems to ensure rapid, automated alerting of shore-based communication and rescue authorities, in addition to ships in the immediate vicinity in the event of a marine distress. The full implementation of the Gmdss on the 1st of February 1999 was an important date in maritime history, coming almost exactly 100 years after the first use of wireless technology to aid a ship in distress. Italian engineer Giuliano Marconi invented the radio in 1895, and the first use of wireless in communicating the need for assistance came on the 3rd of March of 1899, when a freighter rammed the East Goodwin lightship, which was anchored 10 miles offshore from Deal in the Straits of Dover, off the southeast coast of England. A distress call was transmitted by wireless to a shore station at South Foreland, and help was dispatched. It was soon clear how valuable wireless would be in saving lives at sea. But wireless had its limitations, notably in terms of the distance that could be covered. In the 1960s, the IMO recognized that satellites would play an important role in search and rescue operations at sea, and in 1976, the organization established the International Maritime Satellite Organization, which later changed its name to the International Mobile Satellite Organization, to provide emergency maritime communications. In 1988, IMO's member states adopted the basic requirements of the Global Maritime Distress and Safety System, or GMDSS, as part of SOLAS, and the system was phased in from 1992 onwards. Today, the GMDSS is an integrated communication system, which should ensure that no ship in distress can disappear without a trace, and that more lives can be saved at sea. Under the GMDSS requirements, all ships are required to be equipped with satellite emergency position indicating radio beacons and Navtex receivers to automatically receive shipping safety information. The GMDSS communication system under SOLAS complements the International Convention on Maritime Search and Rescue, 1979, which was adopted to develop a global SAR plan, so that no matter where an incident occurs, the rescue of persons in distress will be coordinated by a SAR organization and, where necessary, by coordination between neighboring SAR countries. With the completion of the SAR plans and the full implementation of the GMDSS, seafarers and ship's passengers should feel safer and more secure at sea. The GMDSS Master Plan. The IMO, a specialized agency of the United Nations, regularly publishes a list of planned and operational GMDSS shore-based communications facilities available worldwide. This document is referred to as the GMDSS Master Plan. In order to provide information on shore-based facilities for satellite and terrestrial communication services for the GMDSS, IMO member governments are invited to provide or update the required information for inclusion in the GMDSS Master Plan. Application. All ships subject to SOLAS Chapter 4 have to fit GMDSS equipment. Generally, all passenger vessels and all cargo ships over 300 gross tonnage on international voyages. Implementation of the GMDSS requirements is the responsibility of contracting governments to SOLAS. This means the administrations of individual countries that have ratified the GMDSS requirements into their national law. In practice, it also means that individual ship owners are responsible for ensuring their ships meet GMDSS requirements, since they must obtain certificates from their flag state certifying conformity with all relevant international regulations. Ships fitted with GMDSS equipment are safer at sea and more likely to receive assistance in the event of a distress, Because the GMDSS provides for automatic distress alerting and locating when a radio operator does not have time to send out a distress call. The GMDSS also requires ships to receive broadcast of maritime safety information, which could prevent a distress from happening. GMDSS requires ships to carry satellite emergency position indicating beacons, which float free from a sinking ship and alert rescue authorities with the ship's identity and location. Areas of operation for the GMDSS. As the various subsystems which make up the GMDSS have different limitations with respect to ocean coverage, the equipment required to be carried by a ship is determined by the ship's area of operation. Please check the GMDSS areas and the definitions. Functional requirements for GMDSS compliant ships. Transmitting ship-to-shore distress alerts by at least 2 separate and independent means, each using a different radio communication service. Receiving shore-to-ship distress alerts. Transmitting and receiving ship-to-ship distress alerts. Transmitting and receiving search and rescue coordinating communications. Transmitting and receiving on-scene communications. Transmitting and receiving locating signals. Receiving MSI. Transmitting and receiving general radio communications relating to the management and operation of the ship. Carriage requirements. Equipment carriage requirements for ships at sea depend upon the sea area in which the ship is sailing. GMDSS ships are required to carry the following minimum equipment: a VHF DSC on channel 70 and radio telephony on channel 6, 13, 16. 1 Sart if under 500 gross tonnage, 2 Sarts if over 500 gross tonnage, 2 portable VHF transceivers for use in survival craft if under 500 gross tonnage, 3 if over 500 gross tonnage. A Navtex receiver, an Inmarsat EGC receiver, a 406 MHz or 1.6 GHz Epirb. Details of equipment specifications A1, A2, A3, and A4. Please check the details on the following table. Means of ensuring availability of ship station equipment. The means of ensuring the availability of equipment are determined by the sea areas in which the ship sails. In sea areas A1 and A2, the availability of equipment shall be ensured by using one of the following methods: duplication of equipment, shore-based maintenance, at-sea electronic maintenance, or a combination of the above, as may be approved by the administration. In sea areas A3 and A4, the availability of equipment shall be ensured by using a combination of at least 2 of the above-mentioned methods, as may be approved by the administration. Watchkeeping procedures. Ships, whilst at sea, shall maintain a continuous watch appropriate to the sea area in which the ship is sailing using VHF DSC channel 70, MF DSC distress and safety frequency 2187.5 kHz, HF DSC distress and safety frequencies 8414.5 kHz, and also on at least one of the distress and safety DSC frequencies 4207.5 kHz, 6312 kHz, 12,577 kHz, or 16,804.5 kHz. Appropriate to the time of day and the geographical position of the ship, if the ship is fitted with an MF or HF radio station. This watch may be kept by means of a scanning receiver. VHF channel 16, if practicable. An Inmarsat ship earth station for satellite shore-to-ship distress alerts. A radio watch for broadcast of Maritime. A radio watch for broadcast of maritime safety information on the appropriate frequency or frequencies on which such information is broadcast for the area in which the ship is navigating. A continuous watch for broadcast of MSI shall also be kept for the area in which the ship is sailing by Navtex receiver, Inmarsat C or Enhanced Group Call Safety Net receiver, HF Telex. Radio officer. Every ship shall carry personnel qualified for distress and safety radio communication purposes to the satisfaction of the administration. For stations on board ships which sail within the range of VHF coast stations, a holder of a first or second class radio electronic certificate or a general operator certificate or a restricted operator certificate. For stations on board ships which sail beyond the range of VHF coast stations, a holder of a first or second class radio electronic certificate or a general operator certificate. An ORC only covers the operation of GMDSS equipment required for Gmdss C Area A1. Priorities of communications in the Maritime Mobile Service. 1. Distress. The transmission of a distress alert and/or a distress call and message indicates that 1. A mobile unit or person is threatened by grave and imminent danger, and 2. Requires immediate assistance. Distress communications shall have priority over all other communications. 2. Urgency. The transmission of an urgency announcement and an urgency call and message indicates that the following informations refer to an urgent need for assistance, or a medical transport, or a medico call or message. Urgency communications shall have priority over all other communications except distress communication. Ships should discriminate between medical advice and medical assistance. Medical advice is provided by doctors and concerns diagnosis, onboard treatment, etc. Medical assistance provided by the JRCC involves evacuation of a patient subsequent to medical advice being obtained. Medical transports. For the purpose of announcing and identifying medical transports, the following procedure is used. The urgency signal shall be followed by the addition of the single word medical in radiotelephony, or by the addition of the single word medical in NBDP. The use of the signal indicates that the message which follows concerns a protected medical transport. Radio medical advice. The International Convention on Maritime Search and Rescue, 1979, requires parties in the convention to provide, on request, medical advice, initial medical assistance, and medevacs. Terms such as seek radio medical advice appear frequently in shipboard publications, such as the International Medical Guide for Ships, 3rd edition. Communications concerning medical advice may be preceded by the urgency signal. Mobile stations requiring medical advice may obtain it through any of the land stations shown in the list of coast stations and special service stations, and suitable stations listed in the ALRS Volume 1. Numerous coast stations throughout the world offer a 24-hour medical advice service to shipping. Ships can seek a medical consultation about illness or injury by making a radio telephone call, or sending a telex to the appropriate coast station. This radio medical consultation is given free of charge but incurs no responsibility. GMDSS operators should be familiar with the medical pro forma checklist contained in the International Code of Signals and the Medical First Aid Guide of the International Maritime Dangerous Goods Code. These may prove invaluable in conducting radio medical communications, as may the medical section of the International Code of Signals. 3. Safety. The transmission of a safety announcement and a safety call and message indicates that the following informations refer to the safety of navigation: weather conditions, nautical warnings, or to the ship movement communication. Safety communications shall have priority over all communications except distress and urgency communication. 4. Routine. The transmission of a routine announcement and a routine call and message indicates that the following informations refer not to distress, urgency, or safety purposes. Routine communications shall have no priority. Identification of ship stations. Please click the buttons
1.
to proceed.
Ship's
name. 2. Call sign. 3. Maritime Mobile Service Identity. Each ship and coast station fitted with DSC is allocated a unique 9-digit identification number known as an MMSI. 4. Group calling number. Group ship station call identities for calling simultaneously more than one ship are formed as follows. Identification of coast stations. In addition to the call sign, coast stations in the maritime radio services should be assigned a 9-digit unique coast station identity in the format. Identification of search and rescue stations. When an aircraft is required to use maritime mobile service identities for the purpose of conducting search and rescue communications with stations in the maritime mobile service, the responsible administration should assign a 9-digit unique aircraft identity in the format. Identification of vessel traffic service stations. VTS stations will normally not have call signs. They should be called by the station name followed by its purpose and the word radio, for example. The administration may use the 6th digit to further differentiate between certain specific uses of this class of MMSI, as shown in the example applications below. Admiralty List of Radio Signals. The Admiralty List of Radio Signals series provides comprehensive information on all aspects of maritime radio communications. Volume 1. Maritime Radio Stations. Volume 2. Radio Aids to Navigation, Satellite Navigation Systems, Differential GPS Legal Time, Radio Time Signals, and Electronic Position Fixing Systems. Volume 3. Maritime Safety Information Services. Volume 4. Meteorological Observation Stations. Volume 5. Global Maritime Distress and Safety System. Volume 6. Pilot Services, Vessel Traffic Services, and Port Operations. Frequency and wavelength. Please check the following ITU radio frequency bands and Gmdss usage. Digital Selective Calling. DSC is an acronym meaning Digital Selective Calling. DSC is a paging technique used to automate the initial call between two stations. The technical principles are almost identical to NBDP, in that two-tone information is transmitted from one DSC system to another over a radio link. DSC is used in the MH, HF, and VHF marine bands for distress, urgency, and safety alerting. All controllers feature a distress button that automatically sends a distress alert using pre-programmed information. Features of DSC. Provides a one-touch button for distress. Decreases non-emergency radio traffic on emergency channels. Prevents missed distress calls with continuous transmission. Transmits maritime mobile service identities. Transmits GPS location of caller. Notifies officer and automatically switches to the channel the caller is waiting on. Silence periods. In order to increase the safety of life at sea, Stations of the Maritime Mobile Service normally keeping watch on the frequencies in the authorized bands between 1,605 kHz and 2,850 kHz should keep watch on the international distress frequency 2,182 kHz for 3 minutes, twice each hour, beginning on the hour and at the half hour. With the exception of distress traffic, all transmissions must cease during silence periods. Maritime Safety Information. The Worldwide Navigational Warning Service was established by the IMO and HIO for the purpose of coordinating the transmission of navigational warnings to ships in coordinated geographical areas. In the GMDSS, the Worldwide Navigational Warning Service was included in the systems developed for the promulgation of maritime safety information. GMDSS-compliant ships must, while they are at sea, keep a radio watch for MSI broadcasts on appropriate frequency or frequencies for the area in which it is sailing. 7 categories of MSI are identified as follows: navigational warnings, meteorological warnings, search and rescue information, ice reports, meteorological forecasts, pilot service information, electronic navigational systems updating information. Communication systems. Portable Survival Craft VHF radio telephones. Portable maritime VHF handheld radios can be used for 2 purposes: for distress communications between the mother vessel and life-saving appliances, and between life-saving appliances; for onboard communications between the controlling station and slave stations, and between slave stations. They should be capable of working on Channel 16, Channel 6, and at least 1 other working channel. However, many such radio telephones work on all VHF international channels and perhaps private channels as well. Vessels between 300 and 500 gross tonnage are required to carry 2 portable VHF radio telephones. Vessels over 500 gross tonnage are required to carry 3. Emergency batteries are not rechargeable and are usually kept near or at the rear of the battery charger unit and should be taken to the life raft or lifeboat along with the VHF transreceivers. These emergency batteries have approximately 5 times the capacity of the rechargeable batteries. VHF DSC. VHF. Marine VHF radio is a worldwide system of 2-way radio transceivers on ships and watercraft, used for bidirectional voice communication from ship to shore, and in certain circumstances, ship to aircraft. VHF radio telephone channel plan. Please click the buttons to proceed. The range for a VHF transmission. Transmission range in line of sight, depending on antenna height. Low power 1 watt, range about 4 nautical miles. High power 25 watt, range up to 100 nautical miles. MF, HF, DSC. The Marine MF-H SSB radio is a combined transmitter and receiver, much like VHF. The primary difference between the two is the frequency ranges that they operate in. Typically, Marine MF-HF SSB radios operate in the frequency range of 1.6 MHz to 30 MHz. At medium and high frequencies, reliable use can be made of both the ground and skywave energy components, allowing communications over short and long ranges. MF-HF marine radio equipment will always offer the operator a selection of frequencies in different bands. Example given, 2,182 kHz in the 2 MHz band, 4,125 kHz in the 4 MHz band, 12,290 kHz in the 12 MHz band, etc. This allows the operator to select a frequency which will be suitable for the distance over which communications are required, the time of day, and the season. The concept of HF frequency management. In the different HF bands between 4 MHz and 26 MHz, certain frequencies are allocated for the purpose of radio telephony, radio telex, facilimo, data and transmission. MF-HF DSC. Most DSC systems control the frequency of the associated MF-HF transmitter, automatically changing it to the DSC distress frequency when a distress message is sent from the controller. MF-HF distress frequencies. Whilst at sea, every Gmdss ship shall maintain a continuous watch. Please click the buttons to proceed. Distress procedures using a DSC alert, VHF, and MF-HF. Tune the transmitter to the DSC distress channel. If time permits, key in or select on the DSC equipment board. The nature of distress. The ship's last known position. The time the position was valid. And type of subsequent distress communication. Transmit the DSC distress alert. Prepare for the subsequent radio telephone distress traffic by tuning the transmitter and the radio telephony receiver to the distress traffic channel in the same band, i.e. 2,182 kHz on MF, channel 16 on VHF. Send the following spoken message on the radio telephone channel.
Mayday, Mayday, Mayday. This is Motor Vessel Blue. Motor Vessel Blue. Motor Vessel Blue. Tango, Charlie, Alpha, Bravo, Charlie. MMSI number 2711234556. Position 38.6 degrees north, 026.6 degrees east. We are on fire. Ship is a bulk carrier. Crew taking to lifeboats. Over.
Reception and acknowledgment of DSC distress alerts. DSC distress alerts received on 2187.5 kHz or VHF channel 70 are normally acknowledged by radio telephony on 2182 kHz or channel 16 respectively. Acknowledgement of a DSC distress alert by the use of a DSC acknowledgement message is normally made by coast stations only. Ships receiving a DSC distress alert from another ship should defer the acknowledgement of the distress alert for a short interval if the ship is within an area covered by one or more coast stations. This gives the coast station the time to acknowledge the DSC distress alert first. Acknowledgement of radio telephone. Acknowledge the receipt of the distress alert by transmitting the following by radiotelephony on the distress traffic frequency in the same band in which the DSC distress alert was received, i.e. 2182 kHz on MF, channel 16 on VHF.
Mayday, Motor Vessel Blue, Tango, Charlie, Alpha, Bravo, Charlie, MMSI number 27112345 6. This is Motor Vessel White, Tango, Charlie, X-Ray, Yankee, Zulu 27198764. Received Mayday. My position 20 nautical miles east of Big Cape, proceeding at 15 knots. Estimate at your position in 1 hour. Over.
A ship receiving a distress alert on any DSC channel should immediately listen on the associated radio telephone distress frequency for the voice Mayday message from the ship in distress. Transmission of a distress alert by a station not itself in distress. A station in the mobile or mobile satellite service which learns that a mobile unit is in distress shall initiate a distress alert relay, or a distress relay on behalf of the mobile unit in distress once it has ascertained that any of the following circumstances apply. On receiving a distress alert or call which is not acknowledged by a coast station or another ship within 5 minutes. On learning that the mobile unit in distress is otherwise unable or incapable of participating in distress communications, if the master responsible for the mobile unit considers that DSC distress relay as follows. Tune the transmitter channel. The distress relay DSC equipment. Act on the DSC ship's call or the MMS. The if known. The latest position. The time, the type of sub transmit prepare and the radio band hertz on MF while waiting for the distress alert relay will, after having transmit the information
This is Motor
of a DSC ship from another ship shall follow the same procedure as for acknowledgement of a distress alert. Inadvertent DSC distress alert. An inadvertent DSC distress alert shall be cancelled by DSC if the DSC equipment is so capable. However, in all cases, cancellations shall also be transmitted by radiotelephony.
All stations, all stations, all stations. This is Motor Vessel Blue, Motor Vessel Blue, Motor Vessel Blue. Tango, Alpha, Bravo, 27156. Please of 01.
Action on receipt of DSC distress. The following flowchart. Gmdss Operating Guidance for Masters of Ships in Distress Situations. Please check the following flowchart. Urgency Procedures. The announcement is carried out by broadcast of a DSC urgency call on the DSC Distress and Safety channel. The DSC urgency announcement may be addressed to all stations or to a specific station. The frequency on which the urgency message will be transmitted shall be included in the DSC urgency announcement. The urgency message is transmitted on the radio telephone distress channel. This process is carried out as follows. Tune the transmitter to the DSC distress and safety channel. Key in or select on the DSC equipment keyboard in accordance with the DSC equipment manufacturer's instructions. All ships call or the MMSI of the specific station. The category of the call. The frequency or channel on which the urgency message will be transmitted. The type of communication in which the urgency message will be given. Send the DSC urgency announcement message. Tune the transmitter to the frequency or channel indicated in the DSC urgency announcement message.
Pan pan, pan pan, pan pan. All stations, all stations, all stations. This is Motor Vessel Blue, Motor Vessel Blue, Motor Vessel Blue. Tango, Charlie, Alpha, Bravo, Charlie. MMSI number 2711234556. Position 38.6 degrees north, 026.6 degrees east. I require medical advice. Over.
Reception of an urgency message. Ships receiving a DSC urgent priority message should not acknowledge receipt via DSC, but should tune their MF-HF or VHF transceiver to the frequency nominated in the DSC message and await the voice urgency. Safety messages. The announcement is carried out by broadcast of a DSC safety announcement on the DSC Distress and Safety channel. Safety procedures. The safety message is normally transmitted on the radio telephone distress channel in the same band in which the DSC call was sent. This process is carried out as follows. Tune the transmitter to the DSC distress and safety channel. Select the appropriate calling format on the DSC equipment in accordance with the DSC equipment manufacturer's instructions. Key in or select on the DSC equipment keyboard. Specific areas or MMSI of specific station, if appropriate, the category of the call. The frequency or channel on which the safety message will be transmitted. The type of communication in which the safety message will be given. Send the DSC safety announcement. Tune the transmitter to the frequency or channel indicated in the DSC safety announcement.
Security, security, security. All stations, all stations, all stations. This is Motor Vessel Blue, Motor Vessel Blue, Motor Vessel Blue. Tango, Charlie, Alpha, Bravo, Charlie. MMSI number 2711234556. Position 38.6 degrees north, 026.6 degrees east. There is a floating container. Over.
Reception of a safety message. Ships receiving a DSC safety priority message should not acknowledge receipt via DSC, but should tune their MF-HF or VHF transceiver to the frequency nominated in the DSC message and await the voice message. Similar procedures apply for MF-HF DSC. Radio Telex. In Sea Area A4, NBDP is the only means of communications in which written information on MF-HF regarding safety of navigation can be exchanged. For ships operating in the Sea Area A4, radio telex equipment is compulsory. Radio Telex Basics. The purpose of radio telex in the Maritime Mobile Service is the exchange of information, in direction ship to shore, shore to ship ship, and broadcast to all stations. Two modes of operations are used, dependent upon the message destination, i.e., whether the message is addressed to one specific station or to all stations. ARQ. This is the mode for communication between two stations to transmit and receive information through a certain connection. Own transmission that the to the other. This is the mode for stations in one direction be used for example. Radio answerbacks are used to ensure that two communicating stations are connected to the subscriber they wanted to communicate with. The answerback consists of Telex number, chosen abbreviation, country code. The answerback of a subscriber ashore consists of his Telex number without country code, chosen abbreviation, country code. Please click the buttons. Details of a Telex message. If possible, the Telex message should be prepared in advance by typing it into memory, with the Telex terminal in local mode. This allows editing of the message before transmission. The Telex message format should generally be in accordance with the relevant ITU-T recommendation and include the following information: origin, destination, text of message, signature, end of message indicator. Please hover over the buttons. Distress procedure. Coast stations and ship stations with narrow-band direct printing equipment shall set watch on the narrow-band direct printing frequency associated with the distress alert if it indicates that narrow-band direct printing is to be used for subsequent distress communications. The frequency 2174.5 kHz may also be used for ship-to-ship on-scene communications using narrow-band direct printing telegraphy in the forward error correcting mode. After a DSC distress alert on a suitable alerting frequency, the subsequent distress traffic begins on a Telex frequency associated with the appropriate alerting frequency. Urgency procedure. All messages shall be preceded by the urgency signal pan-pan. After a DSC urgency announcement on a suitable alerting frequency, the subsequent urgency traffic begins on a Telex frequency associated with the appropriate alerting frequency. Safety procedure. Maritime safety information is transmitted by means of narrow-band direct printing telegraphy with forward error correction using the following frequencies. After a DSC safety announcement on a suitable alerting frequency, the subsequent safety traffic begins on a Telex frequency associated with the appropriate alerting frequency. Routine procedure. Working with coast stations. In this example, it is planned to transmit an already prepared and stored message via mobile radio to the land subscriber TR Izmir. This message will be sent to the land subscriber in DIR-TLX mode, which means that the message will be conveyed direct throughout the entire connection. Telex communication. Please click the buttons to follow the instructions. Navtex. Navtex. Navtex is an acronym meaning Navigational Telex. Navtex is a worldwide coastal telex broadcasting system. Coastal Navtex broadcasting stations with specific IDs transmit navigational warnings, meteorological warnings, search and rescue information, and other navigational information for Navtex receiver-equipped vessels sailing in coastal waters. Each Navtex station has an identification code from A to Z. The frequency assigned to Navtex are 518 kHz and another, and many stations exist in the same service coverage. Nav areas of the Worldwide Navigational Warning Service. For navigation purposes, the world is divided into 16 areas. Some indicator characters. Each class of Navtex message carries a different subject indicator character, allowing a shipboard operator to program a Navtex receiver to reject certain classes of messages that are not required. Navigational warnings, meteorological warnings, and search and rescue information cannot be rejected by an operator. Format of a Navtex message. Please check the format of a Navtex message. Broadcast schedules. As there is only one frequency presently used for Navtex transmissions, mutual interference between stations is avoided using time-sharing agreement. In general, each Navtex station in an area is allocated a designated 10 minutes period every 4 hours to make its broadcasts. Details of Navtex stations and their allocated broadcasting times may be found in the list of coast stations and special service stations published by the International Telecommunication Union, or the ALR. Navtex messages are given priorities of vital, important, and routine. Please click the buttons to check the definitions. Satellite communications. Cospas sarsat was initially developed under a Memorandum of Understanding among agencies of Canada, France, the former Union of Soviet Socialist Republics, and the United States of America, signed in 1979. The objectives of Cospas sarsat are to ensure the long-term operation of the system, provide distress alert and location information on a non-discriminatory basis, and support the search and rescue objectives of the International Civil Aviation Organization and the IMO. The system comprises of a space segment operating in low Earth orbit and geostationary orbit, a ground segment consisting of satellite receiving stations, known as local user terminals, and data distribution centers, known as mission control centers. Emergency radio beacons operating at 406 MHz, the characteristics of which comply with appropriate provisions of the International Telecommunication Union and Cospas sarsat specifications. Description of the system. These instruments are capable of detecting signals on the Earth's surface transmitted from distress beacons referred to as emergency locator transmitters, emergency position, indicating radio beacons or personal locator beacons. ELTs are used primarily on aircraft, Epirbs on maritime vessels, and PLBs by individuals on land. ELTs, Epirbs, and PLBs operate on the 406 MHz frequencies and may transmit on 121.5 MHz for homing purposes. The 406 MHz beacons transmit a digital code that contains information about the type of beacon. Each 406 MHz beacon in the world has a unique identifier. The unique identifier allows for registration data and additional information to be linked to each beacon. After receipt of ELT, Epirb, or PLB signals, the satellite relays the signals to a LUT. Epirb emergency position indicating radio beacon. The transmission of an Epirb signal can be considered to be a distress alert. The essential purpose of an Epirb signal is to help determine the position of survivors during SAR operations. The Epirb signal indicates that one or more persons are in distress, that they possibly may no longer be on board a ship or aircraft, and that receiving facilities may no longer be available. Epirbs are small, portable, battery-powered radio transmitters that are both watertight and buoyant, and transmit in the 406.0, 406.1 MHz channel. This transmitted code indicates the particular vessel and the country of beacon registration. A LUT receiving an Epirb transmission would consider that the vessel in distress is unable to transmit a distress message. The transmissions are received by the satellites, which pass on the relevant information to a LUT, which then passes information to rescue authorities via a mission control center. Operation. All Epirbs should have arrangements for local manual activation or float-free release and self-activation. Remote activation from the navigating bridge while the Epirb is installed in the float-free mounting may also be provided. The equipment, mounting, and releasing arrangements should be reliable and should operate satisfactorily under the most extreme conditions likely to be met at sea. Manual distress alert initiation should require at least 2 independent actions: remove a protection facility, then activate the distress switch. Routine maintenance, testing requirements, and test operation. Epirbs incorporate the means to carry out regular tests and indicate the emission of a distress alert or any fault in the equipment. Epirbs should be tested in accordance with producer's manual on a regular basis as follows. Press and release the test button. The red lamp should flash once. The indicator lamp should flash in accordance with the appropriate producer's information. After 60 seconds, the Epirb must switch off automatically. Inadvertent activation of 406 MHz Epirbs. To minimize the possibilities of accidental activation of a 406 MHz Epirb, masters and officers of ships are urged to pay particular attention to the need to educate all crew members regarding the consequences of activation, the need to prevent interference by unauthorized persons, the fact that a float-free Epirb which has been armed will activate immediately on removal from its cradle. If an Epirb is accidentally activated, the nearest coast station or an appropriate coast earth station, or MRCC, RCC, must be informed immediately that a false distress alert has been transmitted and should be cancelled. Inmarsat. The Inmarsat system provides voice, email, telex, data, and facsimile services to shipping. The system also incorporates distress, urgency, and safety and routine communication services. Inmarsat satellites. Inmarsat's primary safety satellite constellation consists of 4 satellites in geostationary orbit, covering the surface of the Earth up to latitude 76 degrees north and south, comprising the IMO C area A3. It can be seen that these correspond to 4 ocean regions: the Pacific Ocean, the Indian Ocean, the Atlantic Ocean East, the Atlantic Ocean West. Inmarsat ground segment. The ground segment comprises a global network of coast Earth stations, or rather, a land Earth station, network coordination stations, and a network operations center. Each CES provides a link between the satellites and the national or international communications network. The large antennas used by the CESs to communicate with the satellite for its ocean region are capable of handling many calls simultaneously to and from the CESs. For each Inmarsat system, a separate NCS is located within each ocean region to monitor and control its communications traffic. Each NSC communicates with the SESs in its ocean region and with the other NCSs as well as with the NOC located in the Inmarsat headquarters, making possible the transfer of information throughout the system. An SES is a device installed on a ship to enable the user to communicate to and from shore-based subscribers via a selected satellite and CES. Inmarsat C. Inmarsat C. The Inmarsat C system does not provide voice communications, but does provide a means of sending text messages or data to and from an SES. Using store and forward messaging. This technique requires a user to prepare the message data on the terminal and then transmit it via the Inmarsat C satellite system. After a short delay, the message data will be delivered to the recipient's terminal, where it may be printed, viewed, or stored. Enhanced Group Calling Service. The Inmarsat system has a capability known as Enhanced Group Calling, which allows land-based organizations, known as information providers, to broadcast messages to selected ships located anywhere within an ocean region. The system also allows for broadcast to all ships within a defined geographical area. This area may be fixed, or it may be uniquely defined by the message originator. Area calls will be received automatically by all ships whose equipment has been set to the appropriate area or recognizes an area by its geographic position. Types of EGC service available. Please click the buttons to proceed. Allows information providers authorized by the IMO to broadcast shore-to-ship MSI. FleetNet allows registered information providers to broadcast messages to selected groups of SESs. The selected SESs may belong to a particular fleet or flag, or be a registered subscriber to a commercial service. Inmarsat and distress. Once the ship in distress selects the distress priority mode and transmits the request channel signal, the call is automatically routed via dedicated landlines to the appropriate Maritime Rescue Coordination Center. Whilst at sea, every Gmdss ship shall maintain a continuous watch for Inmarsat shore-to-ship distress alerts. If the ship is required to be fitted with an Inmarsat SES. The Inmarsat C terminal will provide an audible alert to the watchkeeper when a distress or urgent message is broadcasted by EGC. Long-range identification and tracking of ships. The main purpose of the LRIT ship position reports is to enable a contracting government to obtain ship identity and location information in sufficient time to evaluate the security risk. The LRIT system consists of the satellite communication equipment already installed on board ship, communications service providers, application service providers, LRIT data centers, the LRIT distribution plan, and the International LRIT Data Exchange. LRIT compliance. This equipment can function as a marine communications terminal for the long-range identification and tracking system. The LRIT system is fully automatic. The data listed below is sent by the Inmarsat when it receives a command from the LRIT data center. ID number of this equipment. Position of your ship. Time of position. Sart, Search and Rescue Radar Transponder. Sarts are the main means in the GMDSS for locating ships in distress or their survival craft, and their carriage on board ships is mandatory. The Sart is a small, battery-powered, omnidirectional radio receiver and transmitter. The batteries fitted to a Sart allow operation in the standby condition for at least 96 hours, and a further 8 hours whilst being interrogated. Method of operation of a Sart. A Sart operates in the 9 GHz radar frequency band. On receiving a signal from a ship or aircraft radar, it transmits a series of response signals. The Sart can be activated manually or automatically. The response signals will be seen on the ship or aircraft radar screen as a line of 12 dots, extending approximately 8 nautical miles outward from the Sart's position along its line of bearing. This unique radar signal is easily recognized and allows the rescue vessel or aircraft to locate the survival craft. As the Sart becomes closer, another 12 dots are produced, also 0.64 nautical miles apart. A Sart will not respond to 3 GHz radar. Please check the method of operation of a Sart. Routine maintenance, testing requirements, and test operation. Sarts incorporate the means to carry out regular tests and indicate any fault in the equipment. Radar transponders should be tested in accordance with producer's manual on a regular basis as follows. Switch Sart to test mode. Hold Sart in view of radar antenna. Check that the visual indicator light operates. Check that the audible beeper operates. Observe the radar display. Concentric circles should be displayed. AIS. AIS. The AIS is a data exchange system that transfers packets of data over the VHF data link. It enables AIS-equipped vessels and shore-based stations to send and receive identification and other information that can be displayed on a navigational display. SOLAS Regulation 5/19 requires that AIS exchange data ship to ship and with shore-based facilities. Therefore, the purpose of AIS is to help identify ships, assist in target tracking, assist in search and rescue operation, simplify information exchange, and provide additional information to assist situation awareness. In general, data received via IAS will improve the quality of the information available to the officer of the watch, whether at a shore surveillance station or on board a ship. AIS is a useful source of supplementary information to that derived from navigational systems and therefore an important tool in enhancing situation awareness of traffic confronting users. AIS automatically and at set intervals transmits. Please click the buttons. Dynamic information relating to the ship's course, static information related to the ship's voyage-related details such as destination, cargo information, AIS benefits. AIS has many benefits that can assist in enhancing situational awareness and supporting safety of navigation and protection of the environment, both ashore and afloat. Please click the buttons to follow the items. AIS units are often interfaced to radars and electronic chart display and information system displays. When interfaced to a radar, AIS provides a source of target information additional to that provided by automatic radar plotting aid. AIS system. Please follow the steps. Search and rescue. Search and rescue operation. The International Civil Aviation Organization and the IMO coordinates, on a global basis, member states' efforts to provide SAR services. The aim is to provide an effective worldwide system so that wherever people sail or fly, SAR services will be available if needed. The role of the Maritime Rescue Coordination Center. The RCC is an operational facility responsible for conducting an efficient organization of SAR services and for coordinating the implementation of SAR operations within a search and rescue region SAR action in response to any distress situation achieved through cooperation among SAR administrations. Global Maritime Search and Rescue Areas. The world's oceans were divided into areas or SAR regions for search and rescue purposes, for which contracting coastal states were to be responsible. Knowledge of SAR systems worldwide. Operationally, the global SAR system relies upon states to establish their national SAR system and then coordinate provision of their services with other states for worldwide coverage. The primary system components are communications throughout the SRR and with external SAR services, an RCC for the coordination of SAR services. If necessary, one or more rescue subcenters to support an RCC within its SRR. SAR facilities, including SAR units with specialized equipment and trained personnel, as well as other resources which can be used to conduct SAR operations. On-scene coordinator assigned, as necessary, for coordinating the on-scene activities of all participating facilities. Support facilities that provide service in support of SAR operations. International Aeronautical and Maritime Search and Rescue Manual. ICAO and IMO have jointly developed a manual to foster cooperation between themselves, between neighboring states, and between aeronautical and maritime authorities on SAR. There are 3 volumes of the Imsar manual. These volumes provide guidelines for a common aviation and maritime approach to organizing and providing SAR services. The manual will assist those responsible for establishing, managing, and supporting SAR services to understand the functions and importance of SAR services, relationships between global, regional, and national aspects of SAR, components and support infrastructure essential for SAR, training needed to coordinate, conduct, and support SAR operations, communications, functions, and requirements for SAR, basic principles of managing and improving SAR services to ensure success. The role and method of use of ship reporting systems. Various states have implemented ship reporting systems. A ship reporting system enables the search and rescue mission coordinator to quickly know the approximate positions, courses, and speeds of vessels in the vicinity of a distress situation, by means of a surface picture and other information about the vessel which may be valuable. Example given: whether a doctor is aboard, knowing how to contact the vessels, improved possibility for rapid aid during emergencies, reducing the number of calls for assistance to vessels unfavorably located to respond and reduce the response time to provide assistance. Gmdss Radio Logbook. Gmdss Radio Logbook. Every ship which is compulsorily fitted with a radio installation must carry a radio logbook. The radio logbook must be retained on board for a period of at least 2 years from the last entry. The radio services of ship stations are under the authority of the master or of the person responsible for the ship, and shall require that each operator complies with the ITU radio regulations. Completion of Gmdss Radio Logbook. Please click the button to proceed. Particulars of ship, which must also include method used to ensure availability of service. Section B. Qualified personnel, complete with full details of type of certification and date of issue. Section C. Gmdss Radio Log. This part of the log forms a record of the operation of the ship's radio station and must be completed in duplicate. The following entries must be made in chronological order. Summary of distress, urgency, or safety traffic received either by radio telephone or DSC. Records for distress, urgency, or safety traffic received by Inmarsat satellite systems. Navtex and/or NBDP. These should be noted in and kept with the log. Electronic records of communicating relating to distress, urgency, safety and receipts of weather reports and navigation warnings. Form part of the log and must be retained and not overwritten. Any incident connected with the radio service which appears to be of importance to the safety of life at sea. Test of the Gmdss equipment as detailed in the Gmdss radio logbook. If the ship's rules permit, the position of the ship at least once a day. Please click the buttons to proceed. In addition, the master must inspect and sign each day's entries in the Gmdss radio log. Section D. Details of the radio equipment and battery tests to be carried out by operators. Section D also contains Annexes 1 and 2. Annex 1. Particulars of batteries on board and their purpose. Annex 2. Monthly report on batteries. Sample Gmdss radio log page. Please check the following log page. Phonetic alphabet. Please check the phonetic alphabet table. Morse code table. Please check the following Morse code table. Sources of power. Sources of power. Ships are required to have a supply of electrical energy available sufficient to operate radio installations, and to be able to charge any batteries used as part of a reserve source of energy at all times while at sea. Reserve power supplies. A reserve source or sources of energy are a mandatory requirement and must be capable of powering the radio installation in the event of failure of the ship's main and emergency source of electrical energy for the purpose of conducting distress, urgency, and safety radio communications. The reserve sources of energy should be adequate for at least 1 hour or 6 hours, depending on whether the ship is provided with an emergency source of electrical power. Batteries. The Gmdss requires for the ship's radio station, among others, a power supply of a rechargeable battery. Some equipment like Epirbs, portable VHF transceivers, and Sarts are mainly powered by primary batteries. Charging batteries, battery charging methods. The Gmdss requires an automatic charging system if rechargeable batteries are used as a reserve source of energy. The charging system must be capable of fully recharging the batteries within 10 hours to the required minimum capacity. Please hover over the buttons. Requirements for radio safety certificates. A cargo ship safety radio certificate shall be issued after an initial or renewal survey to a cargo ship which complies with the relevant requirements of SOLAS Chapter 4 by the administration under which flag the vessel is sailing. The validation of the certificate shall not exceed 5 years. Annual radio surveys. The SOLAS Convention sets survey requirements leading to the issue of statutory radio certificates to ships as part of their international certification. The radio equipment may be surveyed at a 12-month or 5-year interval for the reissue of this statutory certificate. Where a 5-year interval is used, the equipment must be inspected annually and the certificate endorsed.